Hello AP Calc AB students, and welcome to video number 4, which really is going to cover example 4 from our topic 6465 lesson. But if truth be told, I'm going to classify this more like example 1 from topic 65, because we're now going to start to get into these contextual applications of using the definite interval as an accumulator. And I've got a really special kind of problem here for you. It's related to something that's going to be near and dear to your hearts here in a few months when you take the AP Calc exam in the form of calc memes. And it also opens the door to a very important genre of question that has been very prominent on the AP exam for really getting pretty darn close to about 17, 18 years now as of the time of this recording. So what are we talking about here? Well, it's the infamous rate in and rate out problems. The examples that are going to follow on the next few pages and in our next 2 videos very closely resemble a type of problem that you're going to see on your AP Calculus exam. And we call these rate in and rate out. These are going to be on your free response part of your exam. They're typically the very first or the very second free response question. They're typically a calculator active problem. And you're going to notice that these full FRQs are going to ask you to find information about uh, uh, this problem that pertain to concepts that you may have been taught in examples or units, I should say, 5 and 4. So we're going to draw upon some really good information from the previous couple of units. So having confidence in these kinds of problems are going to really make a significant impact on your AP score. Due to the likelihood of these appearing on the exam, I also tend in my course to revisit these in topic 8.2. A lot of teachers may not even talk about these until 8.2 because that's kind of where they fit in on the radar, but they're so important that I plant the seed now, and then we're going to revisit it a little bit later on so that you guys get very good at it. And I've been very fortunate that it is one of the strongest parts of the AP exam for my students at Avon High School over the past years. So what kind of problem here are we looking at? Well, to kind of set the stage here before we read this together, every year when students take the advanced placement exam, there's always this funny exchange of social media memes that pertain to some of the questions that students found perhaps challenging or perhaps intriguing or mildly humorous. We've seen problems that dealt with bananas and potatoes and escalators. And so students will post very funny memes with sayings about those particular items like, oh, those things crushed me. Bananas crushed me on the AP exam or something along those lines. So you're going to really get a good kick out of those when the time comes. So here's our problem. It's a calculator active, so you want to pause the video and reach for your calculator if it's not around. After the AP Calc exam, students post memes at a rate of m of t equal 231 sine of pi t over 24 for t between 0 and 24. M is measured in students per hour. T is measured in hours after the AP exam ends, excuse me. After 12 hours, the College Board begins canceling scores of students posting memes at a rate of C of t equal 3e to the pretty nasty exponent here, 0.26439 t squared over 24 for the time interval 12 to 24. Now, the College Board likely isn't going to do that, just so you know, where C is measured in students per hour, T is in hours. S of T is the number of students who have posted memes, but who have not yet had their scores canceled. So we have several different parts to this question. Part A asks, after 24 hours, how many students have posted memes? Round your answer to the nearest whole number. Part B, at time 19, is S of T getting larger or smaller? Explain. Part C, at what time is the number of students that have posted memes but have not yet had their scores canceled a maximum? How many students have posted memes but have not had their scores canceled at that time? Justify your answer. And finally, find S of 24 to the nearest whole number and show the computations that lead to your work. So we've got 4 very legitimate parts to this problem that are significant in that we will use some really good calculus in order to answer them. So let's scroll back up and see if we can start the ball rolling here. Now, I notice at the very beginning we've got some language here. Students post memes, at a rate of m. So it's very important that we know that this m is acting like a derivative. It doesn't have prime notation attached to it, but we want to at least acknowledge that. And then students are then going to have scores canceled, right? So scores are canceled of students at a rate of C, C for cancel. Notice that C is also going to be a rate. And then when it gets to S of t is not a rate, it's an actual number of students. And the criteria is they've posted memes, but have not yet had their score canceled. So we've got really three things that we're juggling here. Now, one of the things that I am a very strong advocate of is that whenever you have a calculator-assisted free response question like this with equations given to you, it's likely that you're going to use those equations multiple times throughout the problem. You can save a lot of valuable time if you store those equations into your calculator, whether you use the TI-84 or the Inspire. Know how to store an equation. So what we're going to do is we're going to go to our good friend, the TI Inspire calculator. I can just work through a scratch pad. If you're using a TI-84, I'll kind of tell you how you would store in that particular model. And I'm going to go ahead and type in m of t, because that is my first expression that I would like to store. And the control math template button there next to the 9 will give me my colon equal. And then if you recall, I had 231 times does not have to be entered, but it's nice to put it in there just to be sure, times the sign, and then I have the fraction, control divide, pi times t, all over 24. And I'm going to hit enter, and when I see the word done, I know that I have stored that particular function. Those of you using a TI-84, you go into your y equal menu and you make this y1, and you will have to use x instead of t. Let's do the same thing for our c of t function, which is a little bit messier, a little bit more going on with that one. If you recall, we had 3 times e, and then we had this exponent that consisted of this very, very grotesque numerator. 2, 6, 4, 3, 9. I want to make sure I get it right. Times t squared, and our denominator was 24. Now, the beautiful thing about this is you will never have to type those equations in again. So let's go ahead and go back to the problem and reread part A and see what we were supposed to do. After 24 hours, how many students have posted memes? Round your answer to the nearest whole number. So what you have to do here is know, what is it that you would do to the rate of memes in order to get the total amount? We've begun to have these conversations. If you have a rate and you want to turn it into a total, you integrate. And we use this kind of funny mnemonic, it rhymes. To find the rate, you integrate. Or I'm sorry, to find the total, you integrate the rate. I got to be careful how I say that. You integrate the rate. So for the total number of memes, which I don't really have a variable I have to give that a definition for, so I'll just dive right in and say, okay, after 24 hours, I know that from time 0 to time 24, when I integrate m, the rate of memes, in students per hour, when that's multiplied by this dt, which is hours, I would get just students as my label, and that's what I'm going to have in this particular problem. So all we have to do is return to our calculator. M of t is already in there, so let's get our definite integral. This might be the first time that you've seen this shortcut, but it's a very nifty one. Shift followed by plus. For those of you that are using the TI-84, I believe you're going to go into Math 9 to pull that up. So we have 0 to 24, and then we just throw in our m of t with respect to t, and if all goes well, we should have a nice answer. Okay, we'll take it, but if we want to convert this to a decimal, I probably could have been better off putting a decimal input in here for those of you that use a CAS calculator, but if I hit Control Enter, that works just as well. Now I have 3529.42, but if we go back and read the problem, it does say to round to the nearest whole number. And so I can just say 3529. I don't have to say students, but it is nice to go ahead and place that in there just to emphasize that. I would certainly encourage you to do that. And a problem like this is typically going to be worth 2 points on the AP exam. You would get a point for just writing out the definite integral of m of t, and then you get a point for basically knowing how to use your calculator to get that result. Let's go ahead and take a look at part B. At time 19, is s of t getting larger or smaller? Explain your answer. Well, before we can really say a lot about s of t, we are going to have to compute s of t. So in order to do that, we have to know that if S is the number of students who have posted memes, but who have not had their scores canceled, then that would be really defined a couple of different ways. In other words, S of t is really just the integration of m of t, very similar to what we did before, but from 0 to 12, it has a different meaning. And I'll tell you what, let's call it this to be more thorough. From 0 to t, where t is between 0 and 12, what does this really mean? Well, that means that students are posting and it's happening, but nobody's having a score canceled yet. So that would be the total number of students who have posted their scores for those first 12 hours. But then we have to consider what happens after those 12 hours. So in other words, we would have the integration from 0 to t of m of t, and we would subtract the integration from 12 to t of c of t with respect to t. Now this is going to be plausible for a time that's greater than 12 hours. And of course, less than 24. Now, I can talk about that again because this is very tricky. In fact, I think that this is one of the trickiest parts of this problem. Once again, when we integrate m, that's the total number of students who have posted a meme. And this t, mind you, can go all the way up to 24 because that's when students have been doing this meme posting, a whole 24 hours after the exam. But if the t is indeed bigger than 12, then we start to have some students who have scores canceled. And so that's why we must subtract the integral of the rate at which scores are canceled to get the total number of students who have been canceled. Students who've posted minus the students who've been canceled are the students who've posted but have yet to be canceled. There's a lot going on there, I know. If that's confusing to you, pause the video, rewind, maybe listen to that explanation again, and it may make sense. Now we end up doing some fun stuff here. Anytime in calculus that you're trying to determine if a function is getting smaller or larger, or increasing or decreasing, we learned in the first semester, we take its derivative. That was a big key component of Unit 4. So if we take the derivative of this s of t, over here we would use that fundamental theorem of calculus that we talked about, where we would just simply take the derivative of the integral, and we could call this m of t minus c of t. Now, let's kind of look at this a little bit more precisely. I would only really need m of t if t was never going to exceed 12. However, if I knew that t was going to exceed 12, I would take the derivative of this integral of m minus the derivative of this integral of c, And this would be perfectly suited if 12 were less than or equal to t is less than or equal to 24. So there's a bit of a different way that you would think about it for time bigger than 12. Now, I know that this problem says at time t equal 19. So yes, I could have completely forgotten that stuff and not even incorporated it into the problem. And maybe some of you were thinking that. But I like the fact that I acknowledged it in case it comes up in a later part of the problem you don't know. And so now we can go ahead and figure this out. What is happening at s prime of 19? Well, s prime of 19 is just m of 19 minus c of 19. Not too bad, right? So I go to the calculator. I go to my calculator, and I would just do that. I would type in m evaluated at 19. I learned my lesson before. I'm going to put a minus in, or a decimal in there so that I get nice decimal output. So I don't have to hit that control enter again. And I get, oh, well, what do you know? I still got some ugly output. That's fine. I'll just hit control enter. If I want decimal, I can do that too. And I get negative 19.42. Let's round that up to a 5. Now, what does that mean? This is negative 19.425. Well, because this derivative value is negative, that means s of t is getting smaller. And you want to write that. S of t is getting smaller at t equal 19. And the reason is because s prime of t, or s prime of 19, is a negative number. And that would do a great job of justifying that part B. Part B could be worth 2 or 3 points depending on the year. You're 5 points into this problem, at least. Now, part C has got some interesting stuff here. It asks, at what time is the number of students that have posted memes but have not yet had their scores canceled a maximum? And then how many students have posted memes but who have not yet had their scores canceled at that time? We want to justify the answer. Well, this is likened to your absolute maximum problem. That's what this is. And an absolute maximum problem, if you recall, is going to invoke the idea of the candidates test. Hopefully that makes a little bit of sense. And if you might need to think about what is the candidates test, you can go back to the very middle parts of Unit 5 and revisit some of those ideas if you feel the need. So what does it mean to find the max or the min? Well, we've already talked about that. It is going to occur when s prime is equal to 0, right? If you remember, we let s be the function that stands for the number of students who have posted but may not have yet had their scores canceled. So I have s prime is equal to 0. So when is s prime equal to 0, one would ask? Well, what is s prime? Well, s prime is the same as m minus c. Well, I think we have equations for m minus c, if I'm not mistaken. So what we can do is we can go back into our calculator here, and there are two different ways that we can do this. One way is if you have a CAS calculator, you very likely can go into your menu, algebra option, and choose solve. And you can solve your m of t that you have stored minus your c of t that's stored, set equal to 0, and just tell the calculator, yep, I would like to solve this for t, please. And then I would also suggest that we tell the calculator we're only interested in, so such that values of our t would be between 0 and 24, because that's the only time that kids are even posting memes. And we end up getting a pretty nasty answer here. So if I hit Control Menu, maybe I'll get a little bit cleaner answer. And I certainly do. I have 2 times at 0.099 hours and at 18.777 or 778 hours. Now, another way to do this, if you would prefer, you could go to a calculator page. Go to your Y1 page and then hit your graph button for those of you on the 84. If you're using the TI, you'll actually have to graph that M of T into this expression. And then it'll be interesting to see, will the calculator like that? Well, no, it thinks that you're going to make a slider, doesn't it? And we don't want that. So you want to cancel that. So instead, into that calculator graph entry, let's change that T to an X. Now the calculator is going to be okay with it. And I know that we don't have a very good scale here. We'll talk about that here in just a little bit. Let's go ahead and bring up our graph entry by hitting Tab, and let's graph C of X at the same time. Because what we're going to do is try to ascertain where these two functions are intersecting one another. But the problem is that we have a terrible window because it's likely that we have many more students than 10 taking this AP exam. And of course, many more of them than 6 or 7, or I'm sorry, many more than 6 taking the AP exam versus many more hours that have transpired. T is in hours, I'm sorry. So what we're going to want to do is probably change the scale. Well, we could slide this around, or we could just jump right to it in the graph menu window zoom. And I'll tell you what I'd like to do for my window settings. I know that I can't have negative time. I do know that my maximum time should be about 24, but I want to be able to see the y-axis. So maybe I'll take this to -4 and I'll take this to like 26 so that I can certainly fit those in my window. And then I could use a scale of 2 so I don't have so many tick marks. A lot of that's very cosmetic. The y values are a little bit trickier. It looks like we may be working with a fairly large number here. So sometimes you just want to play around with it a little bit. And I've kind of messed with this, and I know some values that seem to work pretty good, say -50 to 250 might make the X scale something like 50. And I think that'll give me a pretty good look. I know that you might not be able to do that readily, and you might have to play around with this number a little bit, but you're welcome to do that. Now, there also is some other features of the calculator called Zoom Fit that might work. Sometimes they're a little bit unpredictable, and I like to have a little bit more control. Now, as I said before, if you use a T84, you have to do this. Now, if you use the TI Inspire, you've already found these answers. When we analyze the graph and find the intersection down here, boom, that number very possibly looks familiar. And when we do the same thing, analyze this intersection, we have the same results. So regardless, those two values of T that they are going to be in our candidates. Let's go back to our document. So our values here say that T is approximately 0.099 and 18.778. Now don't forget, we also have to include our good friends, the endpoints. And so we're going to make our T-chart here. And our T-chart's going to consist of those times and the S of T that we're trying to find the maximum number of. And if it helps you, remember, S of T is defined as this guy up here. Whoa, I choose the wrong color there. S of T is defined to be this guy up here. All right. So definitely a long video. Hopefully you're hanging in with this. It's one of our longest ones that we're going to discuss probably. So our T values range from 0 to 0.099 to 18.777 or 18.778. And then finally, let's write that so it's actually legible. How's that? 18.778. and then for good measure, we're going to throw 24 in there. So we just have to test each one of these. And to be honest, it's not going to be as bad as you think, because S of 0 is just going to be the first part of this expression. Now, why do we really just use this part? Well, because our time is less than 12. So this is just the integral from 0 to 0 of that function m. Well, wait a minute. There's no point of even trying to work with this because we know that that answer is going to be 0. Game over. Easy, right? He's all finished. Move on to the 0.099. This is again smaller than 12. So all that you need to do is evaluate this definite integral to figure out how many students we're talking about. So we'll go to the calculator and we'll make this happen. And I'll return to my scratch pad and I use my shift plus 0 to 0.099 of m of t. It's all stored and remembered for me. And I get an answer of ugly. Control enter gives me pretty. And I have 0.148. Boy, that's not many students, right? That's a 0.148. That's not even a full student yet. Well, what's likely happened is we haven't really started to do much of anything because of the fact that it's just shortly out of the gate. When students have left the testing room, we're not even a 1/10 of an hour. And so it's probably not logical that that would make sense. Now when we get to 18.778, this is where things are a bit different. What has to happen here? Well, you're going to go ahead and compute your 0 to 18.778 of m of t, but because this 18.778 is larger than 12, you now have to account for the total number of students whose scores have been canceled. And so you have to integrate the c of t between those boundaries. What's left would be the number of students who have posted but haven't had their scores canceled. So thank goodness for the calculator because he is going to help us greatly here. So what you're going to do is a shift plus. You're going to go from 0 to that 18.778 of the m of t with respect to t. And then we're going to subtract a shift plus integral. We pick up where we left off at 18.778. Up to 24 of our c of t with respect to t. This may give us an ugly answer. That's okay. Let's hit Control Enter, and we have a pretty answer now. Negative 37 point, oops, I think, nope, I made a mistake. Let's see what my mistake is. I don't want this here. I apologize. That won't make much sense. Let's go back and redefine this. What should that lower boundary be? And I am so sorry for this. That should be a 12. We don't start canceling student scores until 12. What I was computing was canceling students' scores after the 18 mark. That will certainly be a different answer. So I can go back to this, and fortunately, we can just copy that and edit it to change this lower boundary to our 12. Now I'll hit Control Enter to get an approximation. And I end up with something that still doesn't make a lot of sense here. No, it doesn't, because my upper boundary is 18.778. Let's go back, and you can see that I'm still not doing this right. Here's why. If t is equal to the 18.778, that's what we want to plug in right here. So, and I say this because these are common mistakes that students can make. And so rely on this equation here that I've highlighted. It's so important that we do that. Now, I promise I won't make those same errors when we do this last part. So now we should probably get something that makes a lot more sense. Once we take care of this and go back in and change this 24 accordingly, we want a positive answer. Control Enter does give us that result. And it makes sense. About 2,000 774-ish students. All right, I believe that next decimal place would be a 4 or a 5. So we go into our table and we'll list that as 2774.474 if we don't round. And then last time with 24. Now 24 would be the integration from 0 up to 24, right? The whole time that students have been posting memes. But then the College Board is wise to that, and then we're going to subtract the integral from 12 to 24 of C of t. Let's see what that's going to give us on the calculator. Another nice thing about this is that I believe that we can just highlight this, hit enter, and we can just change these accordingly and not have to retype them. So a 24 up there and a 24 right there is going to spit out a final result of 0.16. Now that doesn't sound really reasonable, but it is the correct answer, 0.163. And now all we need to do is go into this table, find the largest number, which is clearly this guy right here, but you're going to want to make sure that you draw attention to that. And so we'll just say the max number of students who have posted memes but not have their score canceled. Is going to be 2774. And it does say in the problem up here that we can approximate to the nearest student, 277.4. Okay, and that does happen at time 18.77 hours approximately. We don't need to state that. All right, I know video's long here. You guys have hung in. You've done a good job. This is a real important video. But I want to go ahead and find part D just really quickly or talk about it. It says to find S of 24 and show the calculations that lead to your answer. Well, it just turns out that we've actually done that already. And it's likely that this might have been completely stricken from your notes because it's in the table. And so just to kind of verify, this has already been done up here in this gray. S of 24 is simply the integration from 0 to 24 of m of t dt minus the integration 12 to 24 of c of t. Just this depends on what version of the notes that you have, whether that question is in there. And it's likely that we wouldn't probably have a part D because it's already been discussed. Well, that's your first pretty heavy rate in and rate out problem. You're going to see many more of them. We're probably going to be able to go through them a lot faster in the future too because of the work that you put into this one. Anyhow, we thank you for joining. Our next problem, we're going to take a field trip to the zoo, so stick around for that one.